former. These are our little samples. Well, I cannot say what's acceptable and what's rejectable because it's very dependent upon the code you are using. Now, for example, when I first taught 1104, I cannot believe you can have cracks. I have to read it about 3 times. I'm thinking my mind is playing tricks on me here. Yes, you can have a crater crack, as long as it's not more than 4 mm. But other discontinuities, you would have to look in your standard of 1104, whatever you're using, to find what is acceptable and rejectable. But it is normal that anything on this side here would be totally rejected. Anything in the side, it's not allowed. Usually like sidewall fusion, things like that, it is not allowed.
Excuse me.
Yes?
For this band test, one indicating defect is rejected?
I don't know. It depends on the code you're using.
So one using the code for NDT. NDT, for example, is accepted. For example, the character.
You mean for 1104?
Yeah, accepted.
If it's not more than 4 mm?
After the mechanical test, it should be rejected.
Is it 3, is it?
3, yeah.
Oh, thank you for correcting me. 3 mm. I'm shocked when I see that, because I didn't think they'd accept any cracks at all. Unbelievable, yes? So,
after the mechanical test, it's not accepted because it's shown the defect. So how we can...
well, you've got to look at your standard and see what's acceptable. The dimensions of the defect is dependent upon the standard you're using. It could be, you know, I'm not sure I'm getting your point actually.
But I think the codes are not same.
The codes are not the same, no.
Yeah.
For example, I think ASME is very much stricter than yes, there's different codes. Yeah.
No.
Because NDT will be based on open discontinuities, like you can see either in a radiograph or in... Yeah. So...
Still, it's a question that if the defect was accepted on the NDT, and after that, when we do the bending,
it'll still fail.
Yeah.
Because you can't tell the mechanical properties by NDT. All you got is an acceptable defect.
When we accept it on the NDT and pass it to the laboratory, it's...
the reason why you do NDT is pointless sending something to the laboratory if it's got defects. It's a waste of time.
Yeah.
Waste of time. Because they know for a fact it will fracture. Especially the likes of porosity, things like that will cause weakness within the steel, it'll fracture. Now, reporting of the results, the thickness and the dimensions, the direction of the bend, either being root, face or side, the angle of the bend, either 90, 120, 180, the diameter of the former is typically 4T, 4 times the thickness, and what is the appearance of the joint after bending, the type and the location of any flaws. I can tell you, when I first saw that 1104, which I used to teach, I thought it was 4 mm, actually not 3. It is 3, you're correct. And there is something called a code clinic that goes with 1104 that teaches you how to use it. I'll see if I can dig that out for you. Because before I leave, on your flash drives, I'll give you stuff appertaining to this CSWIP exam for multiple choice, right? But what I want to do is take the stuff off it, give it to me back again, then I'll give you some general stuff that's pretty interesting for you in your job. Okay? I'll show you what I've given you during the break, because I've also given you some plate samples with pictures with defects in them. Or maybe some people have difficulty in distinguishing what is undercut and lacquer sidewall fusion. Okay? That you can study before. So, the next one is the fillet weld fracture. We're coming towards the end of this lecture. We've only got much to do. And then I think we'll have a short break, and then I'm going to give you a quiz. And after that, we're going to start NDT. From NDT, we'll do welding procedures. From welding procedures, we'll do welder quals. Then we will have from welder quals, we'll go to standards, welding symbols today. Then we will look a little bit at the macros. Then in the afternoon, we will do some practical. We'll rearrange the tables for the practical. Okay? Okay. The laptop's not allowed.
Oh, good.
Okay, after break. Take the laptop down, please. Okay, after the break. Not a break yet, though.
Sorry.
We're not finished. Okay, son, no problem. My misunderstanding. You're against. Not a problem, right? Let's finish this and then we'll have a break. It's a short lecture. What is the object of the fillet weld fracture? Is to break open the joint through the weld to meet the examination of fracture surfaces. Well, I'll tell you what the object is, right? If you want to look at the inside of a fillet weld, it's very difficult with MD.